For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@mathsassignmenthelp.com, info@mathsassignmenthelp.com, or reach us at https://www.mathsassignmenthelp.com. Problem 1. A real number r is called sensible if there exist positive integers a and b such that, for example, setting a equals 2 and b equals 1 shows that square root 2 is sensible. Prove that 3 square root 2 is not sensible. Consider only positive real roots in this problem. Solution. The proof is by contradiction. Assume for the purpose of contradiction that is sensible. Then there exist positive integers a and b such that squaring both sides of this equation gives us /b equals, which implies that is rational. Since is rational, we can write it as a fraction x/y in lowest terms, where x is an integer and y is a positive integer. Therefore, we have in the last equation, the left side is even, and so the right side must be even. Since x3 is even, x itself must be even. This implies that the right side is actually divisible by 8, and so the left side must also be divisible by 8. Therefore, y3 is even, and so y itself must be even. mathsassignmenthelp.com. The fact that both x and y are even contradicts the fact that x/y is a fraction in lowest terms. Therefore, is not sensible. Problem 2. Translate the following sentence into a predicate formula. There is a student who has emailed exactly 2 other people in the class, besides possibly herself. The domain of discourse should be the set of students in the class. In addition, the only predicates that you may use are equality and x, y, meaning that x has sent email to y. Solution. A good way to begin tackling this problem is by trying to translate parts of the sentence. Begin by trying to assert that student X has emailed students Y and Z, X, Y, and X, Z. Now we want to say that Y and Z not the same student, and neither of them is X either. mathsassignmenthelp.com. Now, we must think of a way to say that the only people X might have emailed are X, Y, and Z, for all S, X, S, minus S equals X or S equals Y or S equals Z. Finally, we can say there is some student who emailed exactly 2 other students by existentially quantifying X, Y, and Z. So the complete translation is there exists X, there exists Y, there exists Z, X, Y, and X, Z, and 1. For all S, X, S, minus S equals X or S equals Y or S equals Z, 3. Problem 3. Express each of the following predicates and propositions in formal logic notation. The domain of discourse is the non-negative integers, n. In addition to the propositional operators, variables, and quantifiers, you may define predicates using addition, multiplication, and equality symbols, but no constants, like 0, 1. For example, the proposition n is an even number could be written there exists m plus m equals n. N is the sum of 3 perfect squares. mathsassignmenthelp.com. Solution. There exists X, there exists Y, there exists Z, X plus Y plus Z equals n. Since the constant 0 is not allowed to appear explicitly, the predicate X equals 0 can't be written directly, but note that it could be expressed in a simple way as x plus x equals x. Then the predicate x greater than y could be expressed. There exists w, y plus w equals x, and w equals 0. Note that we've used in this formula, even though it's technically not allowed. But since is equivalent to the allowed formula, w plus w equals w, we can use with the understanding that it abbreviates the real thing. And now that we've shown how to express x greater than y, it's okay to use it too. b x greater than 1. Solution. The straightforward approach is to define x equals 1 as for all y, xy equals y, and then express x greater than 1 as there exists y, y equals 1, and x greater than y. C, n is a prime number. mathsassignmenthelp.com. Solution. Is prime n equals n greater than 1, and there exists x. There exists y, x greater than 1, and y greater than 1, and x, y equals n. D, n is a product of two distinct primes. Solution. There exists x, there exists y, x equals y, and n equals x, y, and is prime, x, and is prime, y. E, there is no largest prime number. Solution. Of course, this is a true statement, so it could be expressed by the logically equivalent formula 1 is equal to 1, but even if we didn't know this, we could transcribe the statement directly as, there exists p is prime, p, and, for all q, is prime, q, minus p greater than or equal to q, f. Goldbach conjecture, every even natural number n greater than 2 can be expressed as the sum of two primes. Solution. We can define n greater than 2 with the formula there exists y, y equals 1, and x greater than y plus y. Likewise, n equals 2k can be expressed as n equals k plus k. Then we can express the conjecture with mathsassignmenthelp.com. For all n greater than 2 and there exists k, n equals 2k, minus there exists q, is prime, p, and is prime, q, and n equals p plus q, g. Bertrand's postulate, if n greater than 1, then there is always at least one prime p such that n less than p less than 2n. Solution. For all n greater than 1, minus, there exists p is prime, p, and n less than p, and p less than 2n, problem 4. If a set A is finite, then A less than 2A equals P, A, and so there is no surjection from set A to its power set. Show that this is still true if A is infinite. Hint, remember Russell's paradox and consider, X is an element of AX / is an element of Fx, where F is such a surjection. Solution. We prove there is no surjection by contradiction. Suppose there was a surjection F, a P, A, for some set A. Let W, X is an element of AX / is an element of not Fx, so by definition, for all X is an element of A. But W subset of or equal to A by definition and hence is a member of P, A. This means W equals F, A, for some A is an element of A, since F is a surjection to P, A. So we have from before that X is an element of F, A, X / is an element of F, X, 5. mathsassignmenthelp.com. X is an element of W, X / is an element of not F, X. For all X is an element of A, substituting a for X in 5 yields a contradiction, proving that there cannot be such an F.